Right. It should be starting in just a second. Let me make sure. Okay, it should be started.
Perfect. Thank you very much. All right, everyone. Welcome to today's summer seminar series. My name is Sunil Mathew. I'm a database administrator here at the Center for Pediatric Population Health. And as a database administrator, I facilitate with the collection, management, and analysis of research data, and also assist faculty with the research studies and help with other kind of administrative and day-to-day items at the center. So in today's meeting, we will discuss research data management. It is going to be a very high-level overview of the subject. We'll touch on aspects of data science and data analysis, a little bit of data cleaning, and if we have time, I will try to do a quick demonstration on how to create a database on the fly with you while you're watching, and then we will create some variables and then distribute the database to collect data from you all, and then we'll do a quick visualization of the data. As I mentioned, a lot of this could be kind of covered in a good Wikipedia article. So it is going to be very high level. And if you have any questions at any time, please stop and just ask. I can't see your questions in chat or if you raise your hand or anything like that. So just go ahead and just stop me and then I'll try to answer it. So here's the overview of today's presentation. I'll start off with some of the boring stuff, just providing you definitions, examples of what data is. These are going to be straight up dictionary definitions of data. We'll also talk about how we manage our data here at the center. Hint, it's through databases. We'll talk about the different types of databases, including cleaning, management of data, and prior to putting them into a database, and then how we query the data after it's in the database. We'll also talk about research data and the various sources of where we can find this. And I will give you links or sources where you all can go out and pull data down if you are interested in this topic area and want to try it out on your own. I'll give you links to places where you can get large data sets without having to register, and most of these are publicly available for you. I will also recommend courses that you can take for online learning. So if this is a subject area that you're really interested in, especially research or data analysis, we have a couple of links I can show you where you can do video learning or online learning on these topic areas. And most of these are free, those learning modules. And then the last two portions, we'll talk about REDCap, which is the database we're going to try to demonstrate, and do a quick Q&A section. So data, what is data? So when I was asked to give this talk, I did what most of you did. Most of what you would all do is just Google it. And because we live in a digital information age, my results for data gave me about 8.4 billion results on every conceivable topic on the subject. So let's start off by defining what data is and what we're going to talk about. So data is just facts concerning people, objects, events, or entities. Databases are used to organize data in kind of a structured environment. And then information is data presented in a suitable format for interpretation. So in one way, this is kind of like the flow of how data works for research. There's just a bunch of raw data out there. We organize into a database or some kind of structured system, and then we query that database or source to pull out information, and we publish on it. There's a whole variety of data types out there, and from just Wikipedia, these are like some major types that we have available in our day-to-day life. But in data science, there's really two different types of data. There's quantitative and qualitative. Quantitative data is data that can be expressed as like a number. And whereas qualitative is data that just can't be expressed as a number. It's more categorical in nature. Within quantitative, there's further divisions between discrete and continuous data. Discrete is where it's a whole number, such as the number of students in a classroom, whereas continuous is more on a scale, such as and can be divided into fractional values, so such as what is the temperature outside right now, or the height of the students. Continuous data, again, can be further broken down into interval and ratio. Interval data is data that has equal magnitudes across the various scales, and there's no absolute zero. Whereas, I mean, you can't have an arbitrary zero value. So, for example, Fahrenheit has an arbitrary zero value, but it is not itself like a zero value. In other words, it's not nothing. Whereas ratio is values that are, there is an order, but there is also an absolute zero value. So, for example, heart rate or blood pressure or distance are examples of ratio. On the qualitative side, you have nominal and ordinal. Nominal is data that is kind of like example, like hair color or gender. Whereas ordinal, there isn't an order to the order of how the data is. So example is grades, A, B, C, or D, or F. You know, there's an order in how those values are placed in the scale. And then depending on how the data is, if it's quantitative or qualitative, it'll be handled differently in a database system. And we'll talk about more about that later. Any questions on this? This is probably the most complicated topic we'll talk about. Again, it's very high level, but okay. So let's talk about where we get our data. Not necessarily the center, but where you can get the data that you can analyze without cost for large data sets, if you're interested in analyzing some of this stuff. The data is available almost anywhere. There are numerous credible websites that you can find. I've divided out the data sources by topic area, so government, healthcare, financial economics, or marketing, social media. My recommendation is data.gov. If you want government data, it's really great. If you want census data, also the US Census Bureau has good source. Healthcare.gov is great for healthcare data. Google's Public Data Explorer is great for financial, economic. And if you're kind of more into the social media or marketing, Facebook's API or Google Trends are really great sources. But once we get data, what do we do with it? Other than try to put it into a database, what is like the overall point of data? And researchers, they love to create models. So this is called the DIKW model, which is data, information, knowledge, and wisdom. And the idea is that data itself is useless, but we need to change data into information, into knowledge, into wisdom. And at the center, we do this through analysis, interpretation, and publishing our research. We also use visualizations to create out tables, figures, and interactive dashboards. And so what I mean by this DIKW model is, like the text says on the graphic, data itself. For example, if something is red, is just data. You need to convert that into meaningful information, such as a traffic light is red, and then put it into context. In other words, the traffic light I'm going towards is red, and then wisdom is, oh, it's red, so I should probably stop my car so I don't hit someone. So we're going to focus on databases next. Again, like I mentioned, it's used to organize data into a structure so that it can be then used to publish or to query or to analyze. So again, let's start with definitions. We're going to talk about DBMS, which is Database Management System. That's kind of like the type of program or application you're using to create or maintain a database. Database schema, which is kind of the blueprint or structure for the database, how things relate to each other. Not all databases have a schema. And then SQL, which is structured query language, which is a pseudocode used by most databases to communicate. So when you query something, you probably are using SQL. Even on a website, when you type in something, it may be SQL that it's using when it touches the database that's sitting at the very back end. So there are numerous types of databases, but we're going to be talking about three types, really. There's relational SQL databases, and that's the one we're going to be talking about today. There's non-relational no SQL databases, and no does not mean no SQL. It means not only SQL databases. That's used widely for big data. So your Facebooks and Twitters and all that, they use non-SQL databases. And then you also have your object databases. So that's like your document type databases where you hold files. There are other databases out there, such as hierarchical, column databases, but these are like your main ones that you see every day. The relational SQL database, non-SQL, and object databases. And this is just a kind of a visual of databases that you probably use every day, you just don't know about. So like I mentioned, there's database management systems. So these are all database management systems. This is from 2016. But with the growth of big data, of course, things that are handled by Google, Amazon, Microsoft, Apple, these types of databases have significantly grown, especially on the non-SQL side. There are a variety of databases you probably have never heard of, but you probably use watching on Netflix or Prime Video, or even Microsoft's email system has a database on the very, very back end that manages files. Also, a lot of websites have databases that are attached to them. So when you query something, it goes to a database to retrieve something for you. But one of the best kind of database management systems I like, and technically it's not a database management system, but it works kind of like that, is Excel. And I'm going to use Excel as kind of a framework to explain databases to you all. Since I'm assuming most of you are familiar with Excel and how it looks and how kind of it works. So similar to Excel, in databases, there are tables. And within a table, the rows represent individual records, whereas the columns represent individual different types of fields or variables. So during database development, we need to develop out a database schema or structure to house our data. And we do this by assigning field names, data types, such as if variable is going to contain text or numeric value. And so this goes back to the qualitative or quantitative data types we were talking about before. And once developed out, the schema is used to either import or enter in data. And once also developed out, it is hard to modify. So in other words, once you've collected your data, you can modify it, but it is a little bit more difficult because you have to be kind of sensitive and concerned about losing data when you change something. So for example, if you change a field type that was containing numeric continuous data and you convert it into a text field, so suddenly the data is still there, but it might lose its information, such as numeric values are continuous in nature, and so a 1 comes before a 2, and then 2 comes before 3. So that kind of other information about that information is lost when you convert from like a numeric to a text field. Any questions so far? Okay. So let's get a little bit more complicated. So before I showed you one table, in relational databases, almost always the data is broken up into different tables. And each table represents a certain type of information. So for example, we have your students table at the top left-hand corner, which contains information about students. Right-hand corner is about lecturers. And there is a way that this data is related to each other to create a structure or organization. And we do this in relational databases using primary and foreign keys. So if you look at the courses table, you'll notice that it contains a bunch of ID columns or fields. And these columns or IDs are also found in other tables. So for example, your student table contains a student ID, and your courses table contains a student ID also. So that's what I'm talking about, primary and foreign key. So on your student ID, on your student table is your primary key, and on the courses table, student ID is the foreign key. So using that, there is a relationship between both of those tables. And in this example, we're going to kind of use the courses table to relate all of the other tables together. So that way we can organize a course to directly know, if we query a course, we'll know which students are in that course, whose lecturer, what the subject area of that course is covering. All of that can be easily queried just by going through the courses table. And within the courses table, of course, there's also a primary key for itself, which is course ID. And if you noticed, course ID is not unique, but generally speaking, it usually is. The primary keys are usually unique within a table. And this whole relationship approach, the whole point of relationship databases is to reduce redundant data storage. So if you were to store this as an Excel file, for example, where you don't have multiple tables, but everything's all in one place, you would have to copy this information over and over again. So on the courses table, you would have to have all of your students listed out that are on this course. Even if, and then for the subject, it would be the same subject across the same courses, but you'd have to type that information in multiple times. Now, obviously, relational databases can get complicated. So, that was a very basic relationship. It gets a lot more complicated. So this is another example of, students and courses where there's other tables that are brought in, like exams, enrollment, student attendance, lecture attendance. And so this is kind of an idea of how they all would relate together. And if you notice, the variables or fields that are underlined are the primary and foreign keys within the table, and then those that are not underlined are just your regular variables within that table. So I had mentioned database schema, and the whole point of the schema is when you import or enter in data, it's to ensure the validity of the data. So we don't, so that we make sure that the data that goes into the database is clean and it's accurate and it's just correct for analysis. But if you don't have your schema created correctly, or if you are importing in data from another source, you run into issues where the data is not clean. And so we would need to correct this. So the items highlighted, for example, are values that are incorrect, or they're not incorrect, but they're not in the format that we needed. So for example, the student IDs, if you notice, all of the student IDs start with ST. And so one of the first one that's highlighted, 105, doesn't have ST. So that's not in the schema that we designed it to be. Also, ST105 is also highlighted because student IDs are supposed to be a unique value. In other words, there shouldn't be a repeat in this student table of that student ID twice. In our initial kind of data pull, we can kind of set that if we're pulling a data from an outside source, or we're actually manually entering the data. We can create the schema so that it will not accept a value that already exists or an ID that already exists. However, in this case, it did accept it because it wasn't unique at the time of import or data entry, because student ID was put in as 105 in one record, and then ST105 in another record. So it was not a separate, it was not a distinct value, but when we go and fix 105 first value and put an ST in front of it, then you run into an issue where now you have two duplicate values. And so this is where you can try to automate some of this data cleaning, or worst case scenario, you'd have to go manually and do some cleaning. Other examples are in the next column on first name. So, if we want to do capitalization of the first letter, we can code that in during data import to automatically do it, or that it's a mandatory field. So in other words, if it can be left blank, we can code all of these in. And also code in what we want it to do, what we want the database to do if it fails that check. Do we want to just completely skip the record and not import it in, or stop import process and throw up a kind of a warning message or a flag to see what should be done for that specific record, or just, collect all of the warnings or error messages and flag that record for checking, but import the data in anyway, and then deal with the records that were flagged later on. And usually that's what we do. And one of the worst kind of issues, especially when we go importing data from another source, is the very kind of last record row that I highlighted, which is where GPA and grade level have been swapped. When that happens, you can lose data potentially because of the database schema structure that we have in place. For example, GPA is supposed to contain numerical values. It may not import in the data at all, or it may import in a portion of the data, or you may lose some information with the data during the import process. So that's why we have to be really mindful of when working with data, when we import data and when we manage data, that we don't lose this type of information. So SQL, like I mentioned, is how we talk with databases, how we communicate with relational databases specifically. And this is a very easy looking code, and I've kind of structured it and labeled it so you can quickly kind of understand it. SQL is not true programming code. It's called kind of pseudocode because when you look at it, I mean, you could very easily kind of follow along with what the code is trying to do. So in this example, we always start from the from command, really, when you're reading it. So in this example, we're saying, go to the student table, and then on the student table, find out first name, last name, gender, and course name. And then join the student table and the course table on student ID so that they match up. And then I want you to find where all the students who are female and export them out with the order of with the sorting order of student ID. So the smallest student ID value is at the top and the largest student ID value is at the very bottom. And you can see like why SQL is very useful, because with just this much code, you can query millions of potential students. So like all of you are at a university, so it would be very hard to manually search for every female student, but it's very easy with this just very basic code to query that same information. Having said that, you would have to know how the data schema is and how the data is tables relate to each other. And that's where that join kind of code is important, where you have to know that there is a student ID value in both courses and in the student tables, and that they relate to each other in that primary foreign key relationship model. Any questions on SQL? And SQL query pseudocode can get complicated. It can, and sometimes, most likely, it looks like regular programming code that you may be familiar with. There is a lot of abbreviations you can use. There's a lot of other form like values or system values that you can use, and it can be thousands of lines in code even, depending on what you're trying to do. So
I have a question.
Yeah.
So does this work with any Excel spreadsheet, or do you have to implement it into that specific program to be able to run these like specific to get the specific groups isolated?
What do you mean? So like, can you do like SQL in Excel?
Yes.
You can actually, SQL does support, I'm sorry, Excel does support SQL. You can have your data in what Excel calls not tables, but worksheets. And use SQL to query from Excel the data that contains in that worksheet, and even link it with other Excel or other databases even. So you could query something from Excel, merge it with a database that you already have, which contains some other information, and put all of that data into a third database using SQL.
Okay, thank you.
Yeah, no problem. And Excel is actually one of the most used data sources that we work with and most organizations work with, because one, it's very user friendly. Most people have used it, and it's actually very robust. There's a lot of other things that you can do that Excel has, in addition to just querying information. You can do a lot of cleaning, merges, all of that right within Excel itself. So Excel is a very useful tool to learn, and it's a very easy tool to learn if you want to go and kind of work in this area of research or data management. First, start learning Excel. So regarding research data, so here at the center, we work with a lot of data sources. Our focus is not just on pediatrics, actually. We also work on a lot of public health data, nutrition, obesity. We also collaborate on studies focusing on quality improvement, implementation science, and also adult and even elderly populations. So these are the various sources of the data that we at the center work with. So we have EHR, electronic health data, from health systems such as Children's Health, which is all pediatrics, UT Southwestern, which is for more adults, DFW Hospitals and Clinics, which is kind of an umbrella organization that gets data from most healthcare systems in the DFW area. So in other words, if we wanted to track a patient that was a child that was seen at Children's Health, but then became an adult, went to UT Southwestern, and then later on had an emergency and went to Baylor Scott White, DFW Hospitals and Clinics would probably have that data across all healthcare systems for that specific patient. So we could kind of see that patient's hospital and medical journey or health journey over time. UT Health also has access to Medicaid and Medicare claims data. And we also have other things that we work with. So education data from Dallas IDS, I'm sorry, DIS. Texas Education Agency. We also look at national data such as NHANES, and then, national and federal data like NHANES, HCOP. There's a new data base that we're working on, where some of you may be working on this for this summer, which is the All of Us data set, which tracks about 1 million Americans across the country. And it contains genomic data, survey data, and their EHR, including things like Fitbit data or tracking data, wellness. So that's a new data source that we are working with this summer. And potentially there is a lot of really interesting information that is housed in that data set and that we hope to publish off of. If there is any data at the center that you all are interested in looking at, you can scan that QR code or go to that link, and it'll provide you a PDF file with the large number of data sets that we have available here at the center right now. A lot of them do have kind of conditions that you have to meet. You have to be, for example, any like EHR data, you may have to be credentialed at that organization. So like if it's children's health data, you may have to be credentialed at Children's Health to get access to it. But there are other data sets that are freely available or readily available for you with very little additional requirements. So if that's something of interest to you, go to that website and check it out. And if there is a data set that you're interested in, let me know, and I can help you out with it. And again, this all goes back to that that data model that I mentioned, which is that information itself is useless until you convert it into wisdom, and that's where you all can come in. And that's where we're hoping this summer that you have a little bit of experience in that process of converting data into information, into wisdom, and hopefully even that you can publish that information out to the world. And here at the center, we have various applications and software that we use. And this is kind of a breakdown of the analytical software, the data management, the data visualization software. So for analysis, I always say start off with Excel. That's your go-to, very easy solution to just quickly see what you're about to analyze. There's a whole bunch of tools already in Excel that you can use to do some quick analysis. And then the other stuff, the R's, your SASs, SPSSs, Statas, they require a little bit more programming knowledge to kind of work with. But one of the limitations with coding, and I had this experience recently, which is you could code something and you think you coded it correctly and your data set is looking the way it's supposed to. Because when you work with in a coding environment, you may not be seeing all of the data as you're processing it. Whereas in Excel, you can. So for an example would be like, say in R, you can code out, okay, you want to filter out everyone who's female. Then you're assuming that there's going to be a sample size of 100, let's say, in your data set now. And then you want to drop everyone who is over a certain height or a specific race, and you're thinking that you've correctly filtered out based on a structure that you've created, that you've coded in, but it might not be the case, and your final sample size may be incorrect because you made a mistake somewhere in your coding. Whereas in Excel, if you actually use the filters that it has in place, you can visually see, okay, how many rows or records dropped out when you do each of these incrementing filters. So I would say use Excel, double check your work in Excel if you can, whatever you code in the other data analysis systems, but just double check your information in Excel because it's a great tool to use. For data management here at the center, we use REDCap and Claris FileMaker. REDCap, but both are really powerful. REDCap is more for HIPAA or EHR, electronic medical record kind of related information. It is cleared for housing that kind of information, whereas Claris is not. Claris is more for very customized web-based or app-based data collection that we want to use. And then both of them are really powerful, have a lot of graphical data visualization tools already built in, data cleaning and data management tools. But depending on what type of data we have, we usually break them down into one of these data management systems to organize. And then for data visualization, if it's Map data, we use Esri's ArcGIS, which, for example, if you have patients, if you have their zip code or address, you can throw them onto a map using Esri's software and visualize something. And Esri also has other information that it pulls from its own databases. So, for example, if you wanted to look at patient health, you may pull that information from an EHR system like Children's Health, put it into REDCap to house, export that out, and dump it into Esri, map where these patients are living, and then pull in information that Esri has on, let's say, pollution or nearest parks or gas stations that are nearby. And that can give you an idea of, let's say, why is there more cancer in a specific geographic area? Is there something nearby that may affect patient health? And so Esri is great for that. The other ones are Tableau, which is the little plus signs, and Power BI, which is a Microsoft product, and then Google's Data Studio is the very last one, also called Looker Studio now. All of these are great tools for data visualization. And if data visualization is something you're interested in, and it's a really fast-growing field, try to go learn these tools. They are very easy to learn, and there's a variety of online courses that are available. I want to say the data visualization is probably the easiest thing to learn. Data management is probably the next, and then data analysis is probably the most difficult if you have no coding experience. So having said that, there are numerous online courses or training modules that you can use. Most of them are free or very low cost. Especially, like I said, if you're interested in data science, management, analysis, and if you want to pursue those, this is a very easy way to learn something. And so most universities or organizations have agreements with LinkedIn Learning. So you have free access to these courses. Coursera is a partner that works with a lot of universities to develop out courses and content. And then once you complete a course and any requirements along with it, they offer you a certificate that you can use, put on your resume or LinkedIn profile, or use when you go out into the work environment. So the next thing we're going to talk about, and hopefully, I think we have just enough time to demonstrate real quick, is developing a REDCap database. I highly recommend learning REDCap. It is probably the easiest database you can kind of learn because it requires almost no coding at all. Everything is on a website and it's point and click. And so I'm going to show a demonstration of creating a database in REDCap with you on the fly. Send you all a link to enter in information to the database that we created, and then visualize the data that we've collected. Most of your home academic institutions already have REDCap, and they do have a playground kind of environment that you can just create test databases with and do just to learn the application and work with it and collect data from. And if you don't know your organization's REDCap website, just Google your organization and REDCap. So Texas A&M, REDCap. You Google it, it's probably going to be the first link, please. And right now, just to give you an idea how used REDCap is, as of today, it's being used by 6,599 institutions across the world, across 154 countries, 2.7 million users, and 1.8 million databases created. And it is compliant with a variety of different things. So 21 CFAR Part 11, which is kind of like FDA clinical trials research data clearance. FISMA, which is government information security clearances there. HIPAA, like I said, for medical records clearance, and GDPR, which is EU's data privacy and security clearance. So REDCap is cleared for all of those compliances. So it is good to hold, as good to be used for any of those data sources. And lastly, here's a kind of a QR code or a link that you can go to, and it is a variety of videos that will teach you how to use REDCap in a step-by-step kind of format. So any questions and answers on this this presentation so far, or anything we covered before we go into REDCap? Any questions so far? Okay. Then let me go into REDCap and okay. Okay, so I think you guys can see my screen now again. Should be a web browser. So in the next all of 8 minutes, we are going to create a database, distribute the database, survey, and have you guys complete it, and then visualize it. So in REDCap, we're going to hit new projects, call it fun test database. And this is a practice database, and none of the other information is really important. So our database has been created, and we're going to use surveys. So we're going to turn on surveys. Not going to be longitudinal data collection, and all of that is good. So we're done there. All right, so this is our instrument. We're going to leave the naming like that. And so here's where we're going to create our database fields or variables. So I'm going to send this to you guys. So let's say the first thing I want you to put in is your first name. And we're going to label the variable. So it's going to be name first. No validation. Oh, how about letters only? I'm assuming no one has numbers in their name. So we're going to do that. And it's going to be a required field, and it is an identifier. And we have to specifically note identifiers in REDCap, and that's very useful for data security. And the rest is not that important. So everything else is different. So you saw how quickly and easily we could create a variable in REDCap now. So the other thing I want to do is, let's see, I want to see what is your favorite colors? Colors. So I want to say colors. And we have choices: red, yellow, blue, green, orange, pink, and other. And it is going to be multiple choice. Now, we don't want to drop down where it's a single answer. We're going to do it multiple answers. So it's checkboxes, so you can check these off. And you notice that REDCap automatically codes this. So in other words, red is coded as 1, and so on. I want to manually convert other to 98. And the reason why I like to do this is because, let's say tomorrow I go in and I'm like, oh, you know what? I forgot brown, and I want to add in brown. I can put in 7 brown. And this again goes back to database schema, where we have to be mindful. So if 7 was already coded as other, we would have to code brown as 8 or something, and it kind of messes with the order of how we label the variables, or how we code the variables. I'm sorry. So we call this color. It's not required. It's not an identifier. Done. And let's say next thing we want to do is, let's say, a slider. This is basically something that, yeah. How do you think you did in last exam? And bottom is going to be a 0, 50, and 100 at the top. And these are going to be, we display these values. Oh, so it should be percentages, right? So put percentage values. And we're going to note that it is not and exam score settings. And do we want to write, let's say, want to write a note that it is percent. And the last two kind of questions we want to do are, let's say, what is your favorite ice cream? Ice cream flavor. Okay. Other. There's only chocolate and vanilla for me, so. And again, let's change that to. All right. So that is our survey, and we are going to distribute it. So the survey distribution tools. Oh, okay. So we're going to enable this as a survey. And we're also going to say we're going to pull in a variable, which was name first. Okay, so here's a survey link. I'm going to send it to all of you right now in the chat. And then if you can't see the chat, here's the QR code to scan it. If you want to use this QR code option. And so if all of you can please quickly just enter in the information of the survey. And when you're done, if you can just raise your hand in Teams, and that way I have an idea of who all is done. All right, looks like everyone is done, except Jackson.
Sorry,
right,
I wasn't sure if you wanted me to raise my hand.
I want everyone to participate. So in recap, let's go ahead and visualize what we got. And so there's a stats report section, and let's visualize. So favorite colors. So, there's a lot of blues, pinks, and others. We could have also put in a, fill in the blank option for other, if we really wanted to. How you did on the last exam. So you see how no coding involved at all. It already created a stats table for us with percentiles, means, mins, maxes. You guys are really, really smart. So, favorite ice cream? You guys, no one likes vanilla? Vanilla's gonna be sad. And then this gives you an idea of how many people who started the survey completed it. So we got a 100% completion rate for our survey. So you saw how easy it was to create a survey, or create a database as a survey, distribute it, and visualize it all in one place. We can also export this data out if you wanted to in a variety of formats. So, if there's stat software that you use, that's already built into the system to export out in that file type for you. And then, if you wanted to export out identifiers or not, that's also an option. So that's why it was important to kind of identify which ones were identifier fields and not. All right, so we're 1 minute over, but any questions so far on anything we've covered? Okay. Well, so like I mentioned, if this is of interest to you all, try looking at the LinkedIn Learning or Coursera online courses. Again, most of those are free for you all through your universities. REDCap, again, is highly used across the world for research data collection. So it's something really easy to learn. So check those videos out. And then once you are familiar with data management or data analysis or something, go out to those public data sources that I mentioned, pull down some data and try playing with it. So that way, once you play around with it, that's how you learn the fastest. So thank you again for attending our summer seminar series, and I hope to work with all of you through the summer. All right, take care. Have a great weekend.
Thanks, Sunil.
Thank you.
Bye.
Thank you.
Thank you.